Our second featured speaker tonight is Zoltan Olah. Zoltan works as the project lead on the Meteor project here at MDG. He joined Meteor last year as head of customer success and previously worked as co-founder of Percolate Studio, a digital agency focused on building delightful user experiences. Tonight, Zoltan will tell us some more about the recently released Meteor 1.3. So everybody, please welcome Zol.
All right, thanks, Nick, and hi, everyone. So Meteor 1.3 went out earlier this week after many months of development. It's our biggest release yet, and one that I personally have been madly hanging out for ever since the ECMAScript module spec came out. So this release has a few heavy-hitting features, like the modules. And so in this talk, I'll dive into what problems these features solve and why you should use them. So I'll start with modules because they're so dear to my heart. For a long time, JavaScript lacked module support, forcing developers to use the global namespace. And to work around this, competing solutions emerged like CommonJS and AMD. And this was a great start, but without a standard, code written in the two styles couldn't really operate cleanly. So finally, a standard for modules was ratified in ES 2015. So this is really a really important step, I believe, for JavaScript to be taken seriously as a programming language. And of course, it helps a lot in development. So Meteor 1.3 now fully supports modules. And I want to show you some common problems that modules solve in your daily life. So first up, looking at this code, I'm left wondering what the L function does. And this is a very contrived example. I hope no one out there has ever called a function L before. But I'm going to use it to illustrate a point, right? So before 1.3, a situation like this could arise where it's nearly impossible to track down where something was defined. So this is especially annoying or hard if you're working with an unfamiliar code base, written by others, for instance, or yourself a long time ago. Happens to me a lot. So in this case, in a Meteor app, you'd first search through the app. Next, you'd look through your local packages. And if you still haven't found L, you might look in your packages file to see what packages you're using. Next, you'll have to root around in Meteor's internal folder structure to find the source code for the packages, still looking for L. And then finally, if you still haven't found it, it's possible that L comes from a packages dependency, right? So good luck tracking all that down, and global search probably won't help you there either. So with modules and import, there's a simple solution to this. So that at the top, you can see that L is now imported from this very specific package. So this makes reading code so much simpler and nicer. So even when we know where things are defined, I find it's fantastic to see a catalog of objects that have been imported at the top of your file. You quickly get a feel for the code and the file's dependencies and what areas the code operates on before you've even read any further than the top of the file. So I think imports are fantastic. Another problem for Meteor is this. You've probably all seen that before. So the default behavior in Meteor apps used to be that all files would be evaluated eagerly, and so sometimes it's impossible to get around this kind of craziness in order to get your load order right. So again, imports comes to the rescue, and it's very clean, it's very simple, and now it's possible with Meteor 1.3 to control load order properly without resorting to hacks. And here's another huge pain point for me. Atmosphere has long suffered from the wrapper package problem. And we've sort of thought about various ways to solve it, but it turns out the sort of NPM support that ships in 1.3 just solves it quite naturally. So to give you a reminder, in order to consume packages from the greater JavaScript ecosystem, Meteor authors had to repackage the original code and upload it to Atmosphere. So this approach came with a host of problems, not in the least, pointless labor and lagging versions, and also quality when you weren't sure whether a package was wrapped properly. So NPM, turns out, has come a long way in the years since Meteor has been around. I think if it was in this position when Meteor started out, the project would have just used it. So sometime last year, when I was looking for a simple package called AutoSize, I had the realization that just last year, even some of the less popular front-end only packages were published on NPM by the original author. And that's a really big deal. When you get a package from the original author, it just means that it's always going to be up to date, because as soon as they publish it, you now have access to that version. You don't have to wait for a wrapping package sort of author to rewrap the original version. So that's a huge advantage. Plus, you're guaranteed of the quality as well because it's coming from the source. So NPM has truly become the standard JavaScript package repository. And I'm so glad to announce that with Meteor 1.3, the giant wrapper package pain may become a problem of the past. So here's the solution. You use npm install with Meteor 1.3 to natively install the package in your app. And then you import it, and you just begin to use it straight away. And if the original author ever updates the package, it's very simple with NPM to just update the package, and then you continue using the new features. Furthermore, packages from other ecosystems like React and Angular that live in NPM and are modularized can now be much more naturally consumed in a Meteor app. For instance, in this example, you can see I pull out router and route and link, browser history, directly from within the React router package. This wasn't really previously possible without a complex wrapper package that exposed all of those different internals. So next I want to touch on testing, which is another headline feature in 1.3. Meteor has a long and sordid history with a lack of great core support for testing. Sure, we used to be able to unit test packages with a quirky internal framework called TinyTest, but that was pretty much where sort of core support ended. So pre 1.3, in order to test the app itself, you had to awkwardly break it up into local packages and then test those with TinyTest, which was sometimes a pretty contrived exercise. The great folks from the Velocity team, though, picked up the slack where we left off and built out a complementary testing solution. Unfortunately, we were busy building other stuff like Galaxy and didn't give them the great support that we should have, I think, to make integration with core totally seamless. So when we were developing the new module system, we found that a lot of the pieces sort of naturally fell into place to open the door for a light but solid solution built into core. So I think the module system opened up that possibility in a really natural way too. And in the end, a lot of the code and the techniques that now constitute Meteor's testing story have come from the original Velocity team and the greater community at large. So I thank you for that. So with the new testing support, you'll be able to use any testing framework to test a Meteor app. Today we have Mocha, and in the future we expect us or the community to build other drivers, for other frameworks as well. Thanks to some special naming conventions baked into 1.3, tests can now live next to the files that they're testing, which is a pattern many people enjoy. Although it's not necessary to do that. You can also put tests in their own spot somewhere in the project. And a strong feature that's always been at the heart of Meteor is the ability to test across the client and server divide. So naturally, the new system retains that ability. And it has two modes, unit and full app testing mode. In unit testing mode, your test files are loaded. Only your test files are loaded, enabling you to unit test the specific parts of your code that the test files pull in. And in full app testing mode, your application files are loaded as well, giving you the ability to perform integration testing across your entire app. So that's kind of one of the most interesting features, I think, in the new testing system. And so what we've called sort of full app test mode is similar to end-to-end or acceptance testing, typically using a WebDriver based approach like Selenium. So the difference, though, with end-to-end testing is that you're essentially black box testing your app using a simulated user. Your tests don't have any knowledge of the internals of the application and can only do what the user can do. So this is a great way to make 100% sure that your end user experience isn't broken, but it does come with some trade-offs. And the main one is that it's difficult to seed or reset your data between test runs. If, for example, you have like 100 test accounts in your test run, you'll need to create typically all of that data through the user interface. So you create account after account after account, just like a real user would. And things get especially tricky if you need to create an assertion on some dynamic data that must be seeded beforehand, where the test has to match the actual data that you've seeded. So Meteor's full app test mode is a white box testing approach. That means your test code has access to your application's code and also the database. And this makes it much easier and faster to seed data and write certain types of tests. I think it's also easier to set up and maintain, which hopefully will lead to better tested apps in the future. Next up, 1.3 contains a completely rewritten Cordova integration, which includes much better performance, both for your application, thanks to like WK web view support, and also for loading new app versions when you push an update. And that's thanks to a better download algorithm, and that includes download resumption, which was sort of an obvious feature that was missing previously. And incidentally, that feature leads to lower data consumption as well, which is really useful. So I think combined with the Android crosswalk support that we launched in 1.2, it's now possible to write, I think, like really cutting edge hybrid web apps really easily with Meteor, because all of these great pieces come out of the box that otherwise you'd have to spend a lot of time assembling yourself. And in particular, this is a pet peeve of mine because I've seen it a lot. Was a fault of the previous Cordova system where if you deployed an app that was broken on startup, it would essentially brick the app on the phone. And then you'd have to, once you pushed a fixed version up into the cloud, you'd have to ask your users to basically uninstall the app and reinstall it again to get a working version. So that's really, really bad if you have to do that. You might even lose users over that. So with 1.3, we've included a safety belt feature that means you'll never be in this situation, because if a version doesn't boot, the app will just roll back to the previous version or whatever came from the App Store to begin with. Also, another noteworthy little sort of set of options that we landed in 1.3 gives you the ability to tune live data performance. So we typically recommend that everyone should use oplog tailing for the best performance in their apps. And this is true for most situations, I'd say 95% of situations. But there are some edge cases where the old poll and diff algorithm works better. For instance, when data changes more frequently than your users need to know about, that's one of those situations. So remember that, like with oplog tailing, every single change needs to be processed by the server and sent down to the client. So if you have a lot of these changes that are not important to the user, then you're just generating all of this extra traffic and processing. So imagine like a stock exchange where stocks are being traded really frequently and the users are looking at a stock price. Well, they probably don't need to see the update from every single change. They're probably happy to see a few seconds behind or a minute behind or whatever. So that's a case where the old poll and diff algorithm would be better than oplog tailing for that situation. So we now have this disable oplog option that lets you revert back to the oplog and also set the polling interval and a throttle parameter. I'm not going to go into the details of those parameters because they are covered in the docs, but I think that's a really sort of cool optimization that will help people out. So by now, I hope I've convinced you that updating to 1.3 is a good idea, and it's even worth some minor refactoring. So I'm going to finish the deep dive by going through the steps that I would do to upgrade my 1.2 apps to 1.3. So first off, imports. It's now JavaScript best practice to use import and export, and I expect that'll become the default in future versions of Meteor. So I'd refactor my application code entirely into the imports directory and stop relying on global variables. And then next, I'd refactor my local packages into the imports directory as well. I'm going to savor getting rid of wrapper packages as much as possible. So I'm going to go through my package list to find packages that don't add Meteor-specific functionality and can be found on NPM. And I just NPM install these instead and remove them from my Meteor app as Atmosphere packages. So after or during refactoring code into /imports, I'm now perfectly positioned to take advantage of the new testing infrastructure. So I do that probably by writing tests in line with my application code. If I'm using Cordova, I definitely republish my apps with the new functionality, and it does require a binary update, so you will need to republish new apps to the stores. And I'll point out that because of this binary incompatibility, 1.2 apps won't automatically hot code reload to 1.3, and vice versa. 1.3 apps won't try and hot code reload down to a broken 1.2. So you'll need to republish and account for that. And then finally, in Meteor 1.3, we recommend installing React directly from NPM rather than using our previously provided wrapping Atmosphere packages. So when I was getting rid of wrapper packages, I'd just naturally use React directly from NPM as well. And we put a huge amount of effort and work into the Meteor guide in the last sort of 4 to 5 months, maybe 3 to 4, and then especially for the 1.3 release. The guide is fully up to date with 1.3. It contains a ton of extra content, and in particular, there's a full migration guide from 1.2. So that lists out the breaking changes as well as the recommended updates that we think you should take. And the guide is the place to go for our opinionated voice on best practices for building Meteor apps. It's how we think you should do it, which is something that the community has asked for a long time, and we've shied away from making opinions, but now we're doing it. So having released 1.3, I can assure you we're not going to rest for very long. Up next, we'll be working on stuff like Mongo driver updates, upgrading to Node 4, and also exploring what a full transition to NPM might look like in the future. And more than ever, we'll be paying attention to your needs and taking contributions from the community as much as we can. So thanks for tuning in, and I can't stress enough that you should update to 1.3 and refactor your code. So thank you.
Questions?
Just related to aggregation and improvements in the node driver, when can we expect them, and what's going on with the actual implementation for the full node driver?
So the question was, when can we expect aggregation improvements from the node driver? And as I just said, that's something we'll be looking at very shortly, and also updating to support the latest node 3, Mongo 3.2. Does that answer your question?
As a coder, we need to know.
I'm not going to commit to dates standing up here. I mean, yeah, we just seriously though, we haven't even looked at a schedule for any of this stuff.
Still married to Atmosphere for a little while.
Yeah.
Very good job.
Thanks.
Other questions for Zoltan?
So I've been playing around with looking at 2 different places.
So the question is, are we deprecating Atmosphere, or are people going to have to look in 2 places for packages for the rest of eternity? The answer is, we're still figuring it out. No, that's not really the answer. I think we're going to move to NPM as the package repository for Meteor packages. I don't know whether that'll mean getting rid of Atmosphere or pointing Atmosphere to a subset of NPM where you can search for just Meteor-related packages.
It'd be really nice if Atmosphere was like, a curation mechanism.
Yeah.
Where like, you can see the graph circles, so you can see what's trending up, what's trending down.
Yeah.
And even if Atmosphere was the one-stop shop that pointed, say, to this NPM repository, that'd be cool. It's just like looking in two different places is kind of great.
Yeah. Yeah, and that's what we've seen from other communities as well that treat NPM as a package store. They often build out other little front ends that like only index the packages that are relevant to them. For Ember, for instance, does this. So that's why I say like maybe Atmosphere might sort of look like that in the future. One more?
So I've seen a number of places people asking questions around whether or not Meteor is well suited for big production big application that need to scale.
Yeah.
Can you tell us a bit about it and how 1.3 might be changing that?
So the question was, can Meteor scale, basically? And 1.3 is the release where we've concentrated a lot on making that, on helping projects scale with Meteor. And the focus for this release has mostly been around scaling teams and code base size. You'll see that I talked a little bit about live data improvements. So we focused a little bit of attention on making the data layer scale. But the large focus in this release is making code bases more scalable. So my answer to people is yes, it definitely does. And where the data layer is concerned, my colleague Sashko is going to talk very soon about how we're focusing our attention on making the data layer part of Meteor scale.
We have time for one more question.
One more.
So
Yeah, that's a fantastic question, actually. So the question was, do I need to refactor my entire app immediately if I want to start using modules? Or can I refactor piece by piece, especially as I build out new functionality? And the answer is definitely you can refactor piece by piece. So 1.3 is designed to be totally backward compatible. When you update to 1.3 and you launch your app, it's going to work exactly the same way as it did in 1.2. So we've made modules an opt-in feature. So the way you opt in is there's a /imports directory that now has some special sort of functionality attached to it. And that's where you put anything that's written in the module style. And so you can start now building code in the imports directory with the goal of moving your entire application over into the imports directory one day. And then that's why I sort of mentioned briefly that one day in a future release, we might just say, okay, that's it, like globals are gone. Now your entire app directory just functions as the imports directory. So one day I think we will end up doing that. But for the meantime, it's strictly an opt-in mechanism.
Is that one day, like 6 months from now? A month?
It's 2 weeks. Just joking. No, yeah, it's probably a long way down the track. Yeah. Cool.
Just one more thing. Wrap
One
async,
more.
you still got to worry about wrapping of fibers or any improvements.
Yeah, we haven't done any. So the question is wrap async. So we haven't done any work yet to deprecate fibers. So you will still have to wrap async. Yeah. Cool.
All right, thank you, Zol.